Mutually exclusive events or disjoint events cannot occur at the same time. The two events have absolutely no impact on each other. If you recognize the Venn diagram, we are back to these situations where there's absolutely no overlap. And you can just write a couple things onto the sheet here. Earlier, we called these disjoint. So these are Venn diagrams that have absolutely no overlap. These are the nice questions. They're the ones that you don't have to deal with a lot of complexity. The events have absolutely no effect on each other. But there is a key difference between these questions and the questions that we had last week, because right away, this should look like dependent or independent events, right? Where there's two different things that have no impact on each other. So what's the difference? These are all of the or questions. And so what I always get confused with this is that there are two events. So there are two events that are happening, but the big difference is that it's only one event or the other. So in impact, you actually only have the probability of one thing happening. It's just that you have the two options. So you have to figure them out and then kind of deal with that, which involves adding them. So when you're dealing with a situation like picking a card, getting a 4 or getting a queen, if we're dealing with, actually, let me go back to the earlier ones, the probability of rolling a 5 or flipping a tail, there's absolutely no overlap. There's no relationship there. So we just do the two different questions and then add them. But when we're picking a card, there's only a very specific type of card question that we can now deal with when it comes to mutually exclusive or disjoint, and that are the replacement questions. So if you're doing something like getting a 4 or a queen, what this means is that you have to replace the card. Because if you don't replace the card, you no longer have a disjoint set. So every single time it has to be, out of 52. So let's just do that one on the little Venn diagram here. So I'm going to say that event B is a probability of a 4. Event A is a probability of a queen. And these are nice because this is the fastest kind of question that you have. Before I put the answer onto the Venn diagram, let's just do it over here. Hopefully you can see it. Probability of a 4. There are 4 different cards that are 4s out of 52 total. So that reduces to 1 over 13. And probability of a queen is the exact same thing. There's 4 queens out of 52. And that reduces to 1 over 13. This does not work if I did not write that there's replacement. Okay, you have to go and replace the card once you look at it. So you draw that card, you see it's a 4, you put it back in the deck, you shuffle it. If I didn't do that, what kind of question would it be? It was from last week, independent, dependent. It's a dependent situation. But all I want to do here is actually look at these two individual situations, and then I add them. At this point, I'm just doing this to show you the Venn diagram. So how you would label your Venn diagram with probability is to actually write the fractions here. And it's way better with the fractions because it shows you that of the different situation, there's a 1 in 13 chance, a 1 in 13 chance, and then the outside becomes the 11 over 13. Okay, so my Venn diagram is clearly not in ratio here, but there are 11 over 13 ways of neither of these things happening. Okay, on to the next part. So this leads us to our rules. So when we have mutually exclusive, and every time you see that word mutually exclusive, if it helps, just write down that these are separate circles. I think sometimes in data management, we use these fancy sounding terms like mutually exclusive and non-mutually exclusive, independent, dependent, and we just need to remember visually what they are. So these are separate circles, no overlap. The probability is simply the sum of the probability of the two events separately. So this is the formula that you need to memorize. Or just have into your notes so that you can go and use that. But have you seen this before? Absolutely, because this is just the or situation. So this just means that you have event A or you have event B. So with the example we just did, 1/13 plus 1/13 equals 2/13, and we're done. Okay, on to the next page, where we can actually do a more typical question. So with mutually exclusive events, what is the probability of drawing a 7 or a face card from a deck of cards? We have to do the questions individually first. So I'm going to say, what is the probability of a 7? And because it's an or, I'm going to put my plus sign, or the probability of a face card. So I'm just going to highlight to kind of show the link here. The word or becomes the plus sign. And then I have to pause for a second and ask, is there overlap or is there no overlap? Is it possible to have a 7 that's a face card or a face card that's a 7? Okay. So if this had said a 7 or a red card, I would have to pause, because you can be a 7 in a red card or a 7 in a black. But there's absolutely no overlap here. So in this case, there is no overlap. And what that means is that we are correct for mutually exclusive. So no overlap means mutually exclusive, separate circles. So down on my circles now, I can say this is a probability of a 7. And this is the probability of a face card. And now I just go to the answer. Probability of a 7. I'm going to go, yeah, no, we'll keep this in out of 52. We can reduce it at the end. 4/52 is the probability of a 7. How many face cards are there? Jacks, queens, kings all have faces on them, 4 of each. So we have 12 face cards out of 52, giving us 16 out of 52. And that reduces down to 4/13. So that is my actual answer. The probability of a 7 or a face card is 4/13. But on the Venn diagram, and if you can kind of draw your Venn diagram properly, because I'm missing the box, which is very important. The S value on the Venn diagram for all probability questions, it's just 100%. If you wanted to, you could write 52 out of 52 to go and show that, but just 100%. And why does the 4/13 not show anywhere on the Venn diagram? Because it's the combination of both circles. So what's going to be on the Venn diagram will be a 1/13. So add this to your Venn diagram here. A 1/13 for the probability of a 7, a 3/13 for the probability of a face card, and then that gives us on the outside 9/13. So when I ask you to label a Venn diagram, that's what you'll need to do. Non-mutually exclusive events can occur at the same time. So when we get this word non here for the non-mutually exclusive events, write down, this is the situation where there is overlap. So 2 different things can be happening at the same time. Non-mutually exclusive events can occur at the same time. We're now in the situation where our Venn diagrams overlap. So let's just jump right into an example with this. What's the probability of a diamond versus a probability of a face card? I'm going to leave drawing this for a little bit because it does get a little bit complicated. So let's just look at the individual probabilities. So probability of a diamond, I'm going to try to draw one here, plus, because it's an or situation, plus the probability of a face card. And we are actually going to have to come back and modify our formula a little bit, but we'll come back to that. We'll do the part that we know. Probability of a diamond, there are 13 diamonds in a deck of cards over 52 cards. And we know from our previous question that there are 12 face cards. And that's over 52 as well. And why does that give me the wrong answer? 13 over 52 plus 12 over 52. Yep. You got it. There are 4 diamond face cards, or 3 of them, sorry, Jack, Queen, and King. There's 3 diamond face cards. And so we've gone and overcounted. So I'm going to show how the formula works. And then after that, we'll go 13 over 52 plus 12 over 52. Go back to your formula here. We now need to subtract the probability of diamond face cards. We've double counted. By counting every diamond and every face card, we've just double counted. We've counted them twice, so we need to subtract those. We have 3 cards that are both diamonds and face cards over the 52. And now that goes to 22 over 52, reducing down. You can just go right to the final answer. 11 over 26 is the actual answer to the question. And that is because of the overlap. Okay, now what gets a little tricky is doing the diagram on this part. So I'm going to do my best to kind of show this. If you have different colors, that's probably best to go and deal with. I'm going to purposely do these little kind of cross hatches here, but leave enough room to go and kind of write a bit of a fraction that's in there. So that's my portion that's in red. And then I'll go this way kind of for the other portion here. And the challenge that we have is that the entire face card circle is 12 over 52, and the entire diamond circle is 13 over 52, but neither of those numbers actually go on to the Venn diagram. And so I'll kind of come back to that in a second. What is the number we actually have to start with? It's the overlap. That is the most important thing here. So the probability of A and B together is the 3 over 52. So that's kind of the middle portion that we have. And then in order to figure out the other parts, like the diamonds and the face cards, I need to subtract the 3 over 52 from there. So the 13 over 52, that is all of diamonds, becomes 10 over 52. And the 12 over 52, that was all face cards, becomes 9 over 52. And this tends to be the one time where we don't reduce fractions. You can, you're not going to lose marks for that. But when you have a situation where it's a deck of cards, there's something good about knowing what the ratio is out of 52 for all of them. How do you figure out the outside portion? It's going to be, so the 30 plus the 10 plus the 3 plus the 9 gives you the 52. Quite frankly, if you were writing a traditional exam, this would be important. When it comes to doing multiple choice, are you ever going to have to draw an entire Venn diagram? No, you're just going to have the little pieces to be able to identify for it. So this sometimes frustrates people. If you understand this, getting the actual answer of a probability of a diamond or a face card is 11 over 26. That's great, because that would be a multiple choice question. The other thing would be, what is the overlap? So looking at your diagram, probability of A and B would be 3 over 52. Practically, you're not going to have to label an entire one. Okay, let's finish off the looking at the formulas here. So when you have non-mutually exclusive, if an event is not mutually exclusive, you need to subtract for the double counting, which is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Where have you already seen this formula? It's actually not new. This is the exact same formula as the union of A and B. Let me just go and write this out to you, sorry. So where have you seen this formula before? This is the union of A and B. So with Venn diagrams where you had A in union with B, it was equal to the number of A plus the number of B minus the number of A intersect B. It is the exact same formula as Venn diagrams. The only difference is that we're adding the probability now. So if you have the probability of A or B, this is the exact same situation as the union of a Venn diagram. What's the difference? Before we had, if it was a deck of cards, we would say S is equal to 52. Now it's S is equal to 100%. And we just write all of the numbers in fractions to show the probability. Final thing here, and then we'll get into some of the homework questions. What is the difference between independent events and mutually exclusive events? Couple of things to go and write down here. So independent events is what we did last time. Mutually exclusive events is what we did today. When we're looking at them, the key here, be sure to write this down because this will help with some of the visual side. Both have the exact same Venn diagram. They are disjoint. So they are disjoint. There is absolutely no overlap. So that's for both. So what's the difference here? When it comes to independent events, so I'm just going to do this one over at the side here. When it comes to independent events, this is the situation where you're using the word and in the question. And so what this will look like will be the probability of A times the probability of B. So that's for independent events. For mutually exclusive events, this is the situation where you're dealing with the or. That mean it's the probability of A plus the probability of B. That's it. That is the only difference between independent and mutually exclusive events, is that one question deals with the and independent, one deals with the or. The diagrams are the same. The lack of overlap is the same. It's just whether you're adding or multiplying. You see how important this sheet is when you're doing your quiz and your exam, your mini exam. Is you kind of do it as a choose your own adventure. Do I have overlap? No. Is it an and situation or an or situation? And then this is the formula that I use. So let's do the same thing here for mutually and non-mutually exclusive. Diagram is again going to be the same, but the diagram is going to have overlap. So we have the overlap in this situation. With mutually and non-mutually exclusive, we do have overlap, so overlap exists. So now what's the difference between the dependent and the non-mutually exclusive? The dependent is the and question, and the non-mutually exclusive is the or question. And then we have those formulas that we already covered today for that. Non-mutually exclusive, you have to subtract the overlap. Dependent, you have to change the fraction as you go.